The little circuits that we use in the labs use DC current, or more properly, direct current. This means that the current flows one way only in the circuit. It may be constant in size, for example, if it's from a battery, or it could be varying. If you look at the DC output of a power pack with a Crow, you will see that there's a slight wobble in the output. This is because the power pack runs on AC, it contains transformers, and then uses smoothing circuits containing capacitors to make the output voltage fairly constant. But most of our appliances run on AC, or alternating current. We're going to look at why further on when we're looking at transformers. So what happens is that the potential at the active wire will be alternating from positive to negative in a repeating curve that is a sine curve in shape. This makes the current in AC appliances wash back and forth rather than just running in one direction. You would have seen in your mechanics course that simple harmonic motion is related to circular motion. An AC generator spins in a circle, and that makes the voltage output follow the curve that we see in simple harmonic motion, which is a sine curve. We'll look in more detail at how generators work when we look at electromagnetic induction shortly. But for now, we can see that the voltage is going to be in the form V equals Vm, which is the maximum voltage, sine omega t. And current, which is V over R, will be I equals I max, sine omega t. And omega, remember, equals 2 pi f. In power stations in Australia and in most of the world, the frequency f is about 50 Hz. So the potential at the active terminal is constantly changing and will have a shape like this. You can see at top and bottom the symbol for an AC voltage source. It has a little sine curve in it. But how do you give a value for that voltage? Obviously you can't use the average, it would just be 0. But we don't give the peak voltage. We use something instead called the root mean square, or RMS voltage. To work that out, we start from a voltage curve that looks like the sine curve in the dark purple. It varies from plus Vp to minus Vp, where Vp is the peak voltage. If we square the whole thing, all the negative parts become positive, and the V squared curve varies from 0 to Vp squared. Then we can take an average. The average of that V squared curve is half of the peak value. So once we take the average, which is half, we then take the square root, and that lets us define an RMS voltage that equals the peak voltage over root 2.